Hi, in this video I'm going to teach you how to find the derivative of a function using another rule we call the chain rule. To know when and how to use the chain rule in finding the derivatives, let us use the following examples. To find the derivative of y equals 3 times x plus 2 squared, what we can do is to expand the expression and find the derivative using the power rule. To do that, so y is equal to 3 times x plus 2 squared is equivalent to x squared plus 4x plus 4. And if you simplify this is 3x squared plus 12x plus 12. Once you have expanded the expression 3 times x plus 2 squared, we will now use the power rule as dy over dx will now be 6x plus 12. Now in letter B, we are given that y is equal to 4 times 3x to the fourth minus 5x cubed, which is raised to the power 10. Unlike the letter A, the letter B is not easy to expand. Therefore, the expanding of the expression before finding the derivative will not be a good option. Therefore, we need another technique in finding the derivative of the function, and that is the chain rule. We can think of the chain rule as an extension of the idea of the power rule. Take a look at the resemblance of y equals 4 times 3x to the fourth minus 5x cubed raised to 10 to that of another function, which is y equals 4x to the 10. If y is simply equal to 4x to the 10, the derivative of y with respect to x is equal to 4 times 10 x to the 10 minus 1, which is 9. So this is equal to 40 x to the 9. So what we will do is we will try to make this look like a 4x to the 10. To do that, we will first assign the expression 3x to the fourth minus 5x cubed by another variable, and let us use the variable u. So if we have u to be the 3x to the fourth minus 5x cubed, notice that the function will now be written as y 4u to the 10. And observe that 4u to the 10 is very similar now to 4x to the 10. And then we will find the derivative of y with respect to x using these two equations. But how are we going to use these two equations? The trick is to get the dy over dx, or the derivative of y with respect to x, for this function. What we will do is we will be splitting this dy over dx into, so take a look at this. So it's like we have dy over dx, but since we introduce a u in the expression, we will first get the derivative of y with respect to that u, and then we will get the derivative of u with respect to the x. And that will lead us to the dy over dx, or the derivative of y with respect to x. This is what we call the chain rule. So we will proceed by following this rule. The dy over dx can be obtained by first finding the derivative of y with respect to the u. Since y is equal to 4u to the 10, we will differentiate this the usual way by using the power rule. The derivative of y with respect to u will be 40u to the 10 minus 1, or u to the 9. And then followed by the derivative of u with respect to x. The derivative of u with respect to x will come from u equals 3x to the fourth minus 5x cubed. So get the derivative of 3x to the fourth minus 5x cubed again by the power rule. This will be 3x to the fourth minus 5x cubed. Derivative will be 12x cubed minus 15x squared. And that we have completed the formula dy over du times du over dx. After that, you have to return the value of u, which is in the expression of x. Take note, u is equal to 3x to the fourth minus 5x cubed. So in the end, we will bring back the expression for x, and that is for the u. The u is equal to 3x to the fourth minus 5x cubed, which is now raised to the power 9 multiplied by 12x cubed minus 15x squared. And that is the derivative of the function given as y equals 4 times 3x to the fourth minus 5x cubed raised to 10. Now, you might want to distribute the 40 to the 12x cubed minus 15x squared, although that is no longer necessary. So you can leave the derivative as 40 times 3x to the fourth minus 5x cubed raised to 9 times the quantity 12x cubed minus 15x squared. Now, let's have a quick review on how we have found the derivative. The first thing to do was to assign a variable for this expression inside the parentheses, and we chose u for this expression, so equals 3x to the fourth minus 5x cubed. By assigning the u, the y became 4u to the 10, which resembles the expression some number a x to the n. Then we applied the chain rule. And what is the chain rule? In getting the derivative of y with respect to x, this will come from the derivative of y with respect to the u times the derivative of u with respect to x. So this process will allow us to first get the derivative of y with respect to u. That will be dy over du, followed by the derivative of u with respect to x. If we will multiply these two expressions, we will get the dy over dx. That is why we had dy over dx equals dy over du is 40 u to the 9 times the derivative of u with respect to x, which is 12x cubed minus 15x squared. And then in the end, we change the u back to its x expression. So we have 40 times the u as a sign is 3x to the fourth minus 5x cubed, 3x to the fourth minus 5x cubed raised to 9, and then copy 12x cubed minus 15x squared. Now that you understand the chain rule, let us simplify the process. Now take a look at this. The given function was y equals 4 times 3x to the fourth minus 5x cubed raised to 10. If you look at the answer, the 40 times 3x to the fourth minus 5x cubed raised to 9 can be obtained by simply performing the power rule. 4 times 10 is equal to 40, and then just copy the 3x to the fourth minus 5x cubed, which is now raised to the 10 minus 1, which is 9. And followed by 12x cubed minus 15x squared, which is basically the derivative of the expression inside the parentheses. Remember, this was our u before, and the du over dx is 12x cubed minus 15x squared. So getting the derivative of this will give us that 12x cubed minus 15x squared. So this is the more straightforward approach in applying the chain rule, because some people are confused when they think of dy over dx is equal to dy over du times du over dx. But take note, this answer was basically obtained by this, but you can simply think of it as an extension of the power rule. Just never forget that when you apply the power rule by using 4 times 10, which is 40, we copy what's inside the parenthesis, and then the 10 becomes 9 because of the 10 minus 1. There's always that derivative here, which will come from the expression inside the parenthesis. Now, to fully understand that, let's use another example. Let us take, for example, y is equal to 6 times 4x to the 9 minus 6x squared raised to 20. To get the derivative of y with respect to x, use the power rule and think of this as a single value. So this will be 6 times 20. Remember, we multiply the exponent and the number. 6 times 20 is 120. We copy whatever is inside the parenthesis, and then the 20 will become 19 because we have to subtract 1. Remember the power rule. But in the end, do not forget to multiply this by a certain derivative which will come from the expression inside the parenthesis. So 4x to the 9 minus 6x squared, the derivative is 36x to the 8 minus 12x. And that is already the derivative of the function using the chain rule, or the simplified. We could say the simplified chain rule. Now, if we have let u be equal to 4x to the 9 minus 6x squared, it should be clear that this first expression came from dy with respect to u, the derivative of y with respect to u, while the 36x to the 8 minus 12x is the du over dx. Now, if there is an expression like, let's say there is no number before the parenthesis, let's have a simple 2x to the 5th minus 4x cubed raised to 5. So if there's no number here, we know that that number is equal to 1. So the derivative of y with respect to x will simply 1 times 5, which is 5. We copy 2x to the 5th minus 4x cubed. Now this is raised to 5 minus 1 raised to 4. But don't forget, there is this derivative that will follow this expression, and that is the derivative of 2x to the 5th minus 4x cubed. So times 10x to the 4th minus 12x squared. And that's how you apply the chain rule. So with these examples, I hope that the use of chain rule in finding the derivative is now clear. Always remember that the chain rule is just an extension of the power rule. Now, before I end this video, let me give you an exercise that you can try so that you will be able to test your understanding of my tutorial. Here's the exercise for you. You may pause the video now and then play the video again so that you can see the answer. And the derivative is f prime of x equals negative 35, 6x to the 4th minus 5x squared plus 2x raised to 7 minus 1, which is 6, times the derivative of the expression inside the parenthesis, which is 24x cubed minus 10x plus 2. So with that, I hope you are now confident in finding the derivative of a function where the chain rule is needed and applicable. Okay, so that's all for this video. Thank you.